So, as Pedro already said, I'm Alex. I don't do slides about myself anymore, but what you kind of need to know is that I'm now kind of involved with my third Istio deployment. All three about with another intake. The first one was more on observability. The second one was more about routing to different kind of machine learning models. And this one, as you maybe guessed, is more tailored to work like identity. So that's why that's what we're gonna talk about. A disclaimer. So there is a lot of text on these slides, and that I know that is against the rules of presentations, but it will make the slides more usable afterwards. So don't look too much to the text. The keywords are highlighted, and for the rest, you don't have to bother. I'll probably tell you what's on the slides. So what's the goal of this talk? So it is actually to gain some deeper understanding on identity within the Istio ecosystem. And having that knowledge will hopefully help you, or at least developers that will deploy on the Istio network, help them design their architecture, knowing that there are a lot of things that they can actually rip out of their code and just rely on. So, and what is it not? It is not, it doesn't talk about any of the hottest new features. All the things I'm going to tell you is already there from day one. It is actually just about the underlying plumbing, and it's actually a talk that I would have hoped that I've got before starting with Istio, but there were no talks at that time. So, because the first time I was involved with Istio, it was version 0.3. So it is actually to make sure to overcome your fears, right? Not knowing what there is makes everything kind of magic. And there is a long quote that I'm not going to quote of an astronaut. It describes in a book that when you do not know any of the concepts, everything is scary. And actually, this is scary if you see it like the first time. If you turn it around, it even looks like a rocket. So, and all those astronauts, they like to understand a bit what's in the rocket, right? So they feel comfortable working with it. So here, this is the purpose of this talk as well. If you want to talk about identity in Istio, there's no way around SPIFFE. SPIFFE is a cloud-native identity spec. It's pretty new. It's a project. Well, pretty new. It's a project on the CNCF, just like Kubernetes and so on. There are already kind of a lot of other projects using it, and it has also its own implementation. But SPIFFE it's a spec. So full out, it's a secure production identity framework for everybody. So I need to Google it every time because nobody really remembers it. Everybody knows it's just like SPIFFE. If you talk about SPIFFE, or actually identity in the cloud, it's kind of tricky. So you could talk about kind of the platform. Maybe you're on AWS and you have some machines. All those machines have a unique identifier. You could talk about that within your network. If you have 5,000 machines, everyone has a unique ID. So you could take that as an identifier. It's kind of tricky when you go cross-cloud. So if you're on Google then and AWS and Azure, you have like your multi-cloud. They're not really compatible. They all look different. They have another way of getting that identifier. So that's tricky. Of course, on all those VMs or nodes or whatever, you have like the host, like the real VM, its operating system. It gets more concrete. In general, it has a host name, an IP address, so you could start talking about that. It's more generic. It works across clouds, right? Because an IP is an IP. But not every IP is directly accessible. Sometimes you have like nets or translation between IP addresses if you're a really big network. Then again, it can gets tricky. And the more and more you cloud native you go, the more and more you're also talking about hosts going away. You're talking actually about processes, right? On Kubernetes, the way you want to get a lot of processes on your nodes, bin pack everything, and those nodes go away, so the processes can go to another host. So the only thing what you actually care about when talking about an identity is how do we identify that process, not that process running on that host on that platform. No, that's that process. We need something stable. So, and that is what SPIFFE actually tries to solve, is how do we get how do we give those processes a stable name? And first of all, we should kind of agree on what do we want to call it. So, and that's why part of the spec is the SPIFFE identifier. So it is actually the core of it. So what is the name of the process? And it's pretty simple. It just says it's a uniform resource identifier, URI. It really looks a lot like your URL that you type in your browser. Although not a lot of people do that anymore, they just Google it. But like HTTP hostname /path, SPIFFE just looks like that. So it starts with its beginning, SPIFFE, and then /hash, so that identifies that this URI is the SPIFFE identifier. And what you have in HTTP as a host name, there you have your trust domain. So that part doesn't identify any machines. No, it is kind of a domain. It's like scoped. Every host name, no, every name within that trust domain is kind of trusted. So it's handed out by a certain authority. And after that, you have a path. So this is actually a valid SPIFFE identifier. It's not really human readable, but it's valid. So you could have like some system that identifies processes by UUID, for example, and then you would have something like that. You could go hierarchical. So saying, okay, we have like a payment system, and that one has its Postgres database, another component, something like that. You could have a mechanism that creates those paths like that, like grouped per service, for example, payments, Postgres, your shopping cart, Postgres, something else, and so on. But actually, in the Istio world, they've chosen a more stable kind of system. Istio is mainly deployed on Kubernetes, so it hooks a bit into that system, where you have the path identified as NS, and you guessed it, it's the namespace, and then /sh chase, and that's the service account. It's an important thing to remember that in Kubernetes is the service account that is used to identify your process. So a good way to freeze to get stable identifiers is that you give each kind of service a stable, its own service account. Already talked about the trust domain, right? That's the first part. Mainly you will see it, if you don't configure anything, it will be cluster local. And that is then within your cluster. Those processes identify each other. But if you grow your network, go multi-mesh or something, you can choose to have each cluster, for example, another trust domain. So you could have like production, staging, or you have your company name in there, and that's kind of up to you, and that really will depend from business to business. So, but it's kind of nice to have like a convenient way to name your processes, but can we trust that identifier? And for having that trust or making sure that we are talking about this process, the second part of the spec is talking about the SFIT, is a SPIFFE verifiable identifier document. Like they have like a lot of long names in that spec, but SFIT for short. Everybody talks about SFIT, and it is actually a way to make sure that that the identifier that we talk about is trusted. And how do we do that? There are two parts in the spec. Two different implementations, right? So it's kind of using SPIFFE using a lot of things that already kind of exist. So it uses or the SWT token. So a lot of web developers and so really like it. You just put that in your authorization. It's just a JSON object, put in an authorization header, and you can decode it. There's certain rules. Istio doesn't use this out of the box, and later on in the talk we'll see why that I would reserve the JWT token for something else. So the current implementation in Istio uses X509 because it uses MTLS. So the spec has 3 parts, but I'm going to talk about the workload API a bit later on, because that's kind of deeper. It lies deeper into Istio. So I'm going to go now to the deeper into X509, but be sure to check out the SPIFFE spec and its kind of sister project Spire. There's an implementation more tailored towards VMs, and they actually work because they have their own SPIFFE identifier, but it works fine. They talk to each other because they kind of know how to assert who's who. So X509. So it's kind of an old technology. It's been updated a few times, but it was first published in like 32 years ago, and it's actually still valid technology. For the youngsters around you, probably it's older than some of you, but it's still used everywhere. So in your browser and for securing networks. People that come into contact with those low-level kind of certificates, this is a common way to distribute your certificates. It's just PEM encoded binary blob. And if you use my favorite tool for decoding that, so OpenSSL. You can actually decode what's in there. So it's a binary blob. You see like a lot of attributes that actually identifies a lot of things. What is the name? What is the signature? An important part there is the public key, and we're going to dive into that directly, and the signature. So every certificate has a public key, and it is signed by generally somebody else. and it has some interesting attributes. And like here, if you look deeply, you will see a SPIFFE identifier. Talking about certificates, right? So to the right, that is kind of each workload will have a certificate, and it will be signed by something that Istio knows, and that has its own certificate. That certificate always comes kind of, the one that owns it always has the private key that is not part of the certificate, that lives outside it. So the one that owns the certificate always has both. The certificate is public. Everybody can have that certificate because it's even passed around. That public key, that's the only thing that needs to be secret. So throughout your workload will have that certificate that identifies the name of a certificate. It will have that SPIFFE identifier in that X509 data, and it will have that public key. And Istio will actually sign it, and we'll go deeper in how it will sign it with its private key. And everybody in the network or in the trust that can look up that trust by just verifying that signature with the public key that they like this. You can have several levels deep. Certainly, if you're planning to go multi-mesh or have want to communicate with Spire or other things, you will probably have like one root certificate. Your Istio in your cluster will have an intermediate, that's the middle part, and you yourself will then have a certificate. And you can nicely see who is signing. The private key is signing the one in the middle, and the one in the middle, the intermediate, will sign yours. And in the other way around, you can verify everything till the root. So you can verify the signature by the public key of your intermediate, and intermediates can be checked with the public one from the root certificate. One special one, it's self-signed. A lot of people probably heard about self-signing. It is just the root certificate is always self-signed. It signs itself with its private key, so you can actually verify that you're self-signed by seeing that you're verifying your signature with the public key in the same certificate. In the previous slides, I didn't show kind of the private key of your own one, because in the signing process or the building of the trust, that private key is actually not really used, certainly not passed around. So with that, in that certificate, you will see then your SPIFFE identifier. You already kind of saw a peek, and so if you dive, it's just the URI, and that's part of the subject alternative name. So there are two parts in your network. So the signing certificates or the intermediate. There are some rules that SPIFFE says, like your signing certificate may not be used for a workload. It can itself be a SPIFFE identifier, but you still cannot assign it. And generally, it's like just the SPIFFE identifier with the trust domain, and has no path component out of it. And the leaf ones for your workloads, it has a full SPIFFE identifier that identifies you. The TLS handshake, that is part of how workloads in the network build trust between the client and the server, right? So I want to go through the messages, how everything is kind of built up, because this is how two workloads interchange those certificates, and it's pretty interesting to know. And I come back after it is something you need to be kind of aware of, is kind of what the implications are, right? So you're a client, you want to start kind of a secured connection So you start with the client here, client hello. You say, oh, these are the ciphers that I support. These are the compression algorithm. Here's some random stuff. And the server, so each block is kind of a message. The server will respond with a lot of other messages. Just saying with the server, hello, okay, this is the cipher I'm going to pick. I'm in control. This is the compression. I know that you understand this. This is what we're going to pick. And here's some random crypto stuff again. So the server is always in control on the cipher. It will also send its public key. Like we said, there's no going around with private keys. It's just saying, here's my public key, and here are the rest of the chain till the root. So its intermediate certificate it will also send. Some server exchange things that's not important in this story. But in MTLS, because we want to trust the client, right? We will both bidirectional trusting. It will ask for the client's certificates in this message. So that's not happening when you're on the web. When you're just browsing, only the server kind of tells the client, here's my thing. That's who I am. In MTLS, here the server wants to know who the client is, and that happens here. Right. So then at the client, it's client's turn, right? It will verify that the signatures, all the 509 bits are correct, right? So it has the root certificate, so it can check all those things, so it can build the trust. But yeah, then it says like, oh, the annoying server wants to know me. Okay, I'll prepare my certificates. I'm going to send it to the server at this moment. An interesting thing is though, and where the private key, and this is where the client really can prove that it's him, because it will use the private key to sign all the previous messages with a signature, and the server can then check that with the public key. So almost finished. So we're wrapping up. The server will conclude. Will check that everything's is verified, is signed correctly, and it will do so by following the chain. So and that's like it's following the chain from the root on, right? Because it knows the root. The client sends all the intermediate, so it has all the information to build the trust. Once that's done, it's kind of, then you have your secure channel, and kind of the client can send its bits and bytes over the channel, bidirectional, right? And then it's just like business as usual. You can see that it's kind of a ping pong, certainly in the beginning. So this is why well worth to know that it's good that you keep connections open, right? And that you work like if you want to have your SSL pipe open, and not do that for like if you want to send 5 bits, like start all over, because all the handshaking goes over and over, and it will make it very slow. For 5 bits, it's like more. I don't know how much, but there's like kind of a lot of data sent over left and right. So voila. So that's kind of important. So after the TLS handshake, you have your pipe, but also both parties know who's who. An important building block. So after kind of all the SSL part, because we still talked about kind of implementation, who's doing actually the hard work. So and that's Envoy. So within Istio, Envoy is actually the real worker. So if you have like Istio as an ant colony, then Envoy would be really the worker ant. So the typical, if you see the typical Istio diagram, right? It's everybody will have slides like this. You will see envoy, 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 envoy. So I've left out the control plane because we're going to talk about that later on. But every workload has its own envoy. You have like ingress and egress, maybe even multiple ones. That's also just an envoy, and all with its all small blue box. And that's kind of the Istio agent that is running next to it. Interesting to know is that, and I doubt that it's kind of used a lot, but I think it's a very important thing to dive into. It's kind of Envoy can identify to the application running on top of it what the client certificates are. Because remember, Envoy is doing all that handshaking. It's doing that on behalf of the application, right? So your application doesn't even know that there is kind of TLS or secure channels going on. It doesn't know because it just does just lives from its view, lives in an unsecure view world. So it just sends out plain data. Plain, if you're talking HTTP, just plain out. But it's very important that you have that feedback cycle. So Envoy will send like a lot of headers to the application, and the X-forward client certificate is an important one because it just says what the certificate looks like from the client. So these are the ones that it's all part of the Envoy documentation. So those are the blocks that could be part of it. But what is kind of important is the by, the hash, the subject, and the URI. So the by is actually my own. If I'm the server, that's my own certificate to make sure that I did kind of make this or my proxy did make this header. Is a secure hash, the subject, and the URI, and that is the URI from the client. So I actually can identify who the client was, and application-wise, you can do some stuff with it. So in Istio, how does then all those things come together? So you have now one big monolith now, the Istio daemon with some interesting components. So bringing it all together. How is that trust built up? Because your workload, you still need kind of a way to build that trust up, and that's kind of happens in the agent. So it makes like a key value, a private key, and a sign-in certificate. The sign-in certificate is almost a certificate. It sends that to the Istio daemon. Only the certificate signing requests. It can actually verify who it came from, because the Istio daemon uses the token of Kubernetes to make sure, hey, I'm valid. I'm really that person. So Istio daemon can check that. It will create a certificate, and it will send it back to the Istio daemon. Then Envoy has several XDS protocols, and XDS is discovery services. And we're going to use the secure discovery service to send from the Istio daemon to the Envoy proxy. And from there on, we just can do unsecured communication from the workloads, and Envoy proxy will kind of encrypt it all for you. And on the server side, right, it is exactly the same, but in reverse. And here, the last part is where you can then where Envoy will inject those headers, and where the application is kind of can be aware of who the client is. So what's kind of important here is that the identity is established at startup, and that the control plane is only needed when when there's a kind of a refresh. The tokens are pretty short, but Istio daemon can go down without actually the mesh going down, because it just keeps on encrypting and validating, because you have those certificates, they have a certain lifespan, and as long as those lifespans didn't kind of cross, it's all good. How can you leverage that now in your application or architecture, right? So it's kind of important to have like a difference between, to identify a difference between peer and request authentication. So the peer authentication that we talked about is, everything what I said was peer authentication. Who is talking to me, right? And that's how you can leverage. But then on top of it, you can identify request authentication, and if you can use then the authentication for your requests. So from your client, if a client makes a request, it can identify itself, and in general that will be kind of the human. So looking at a non-mesh authority, that's how you could kind of build an application. So you have the JOT token from outside comes in, it identifies the human. But a problem in a not mesh world is kind of that you need kind of, if you pass from the presentation layer to a payment service, you cannot use the JOT token from the user, because you want to actually establish kind of a trust between your presentation and the payment service. So you probably use a JOT token for that. And then how do you pass along the identity from the caller? You can do that in extra headers or something, but there's no real good standard. So in the Istio mesh world, well, it looks like this. Kind of granted, it looks like a lot scarier, but as an engineer's view, it's only this. It can reuse the JOT token, because you don't have to establish trust between your presentation layer and your payment service, because that's done. So I was saying kind of envoy, yes, ingress, right? So ingress, right? That JOT token. So that JOT token, we're not handling it in Istio on how you get that JOT token, and that's generally kind of application specific or something. But it just passes through. The trust is due to MTLS anyway. It goes to your presentation layer. There, something can be done, yes or no, in the application. In general, in the application layer, maybe not, maybe yes. It's all up to the application. But then if you go to the payment service, like in the example, right, you can just pass through the same JOT token. You don't have to translate it anyhow, just pass it through. It goes to the envoy proxy. The trust is between the presentation and the payment anyway. You do have, though, the possibility to have extra policies on the request or on the peer. So I have a quick example, the only CRD that I have here. So that's authorization policy that actually uses both. So you can if you that's a snapshot from documentation, but if you could select your payment service, and in the from section, that is using like the SPIFFE identifier, so cluster local default sleep. If it comes from that, it is a get operation, and the JOT token can be validated. So if the request auth claim is from a Google account, so it is from documentation. So that is the JOT part, and the workload, you can actually allow it or block it at the service level. But as with the X-forward certificate, so if that, you can block it, so you have the possibility of operators or security people to set those security levels, or you have the opportunity in your application to do something with your JOT token, or use the X-forward client header in your application. if you want to be workload aware. So we have like a use case internally that really needs to know what the workload is and what namespace it is to do certain actions. So you have the possibility there. But the nice thing is you really have the choice. You can use both in a mesh, but you have all available in application. You can, but don't have to use it. And if you want to mock it, it's just headers. Then you just can mock a header with job tokens or with export certificates, and that's really something the developers like. No keys to handle that. Just make unit tests with those things, and that's it. So thank you.